2019 Canadian Open Mathematics Challenge Part A. Sean's password to unlock his phone is 4 digits long, made up of 2 5s and 2 3s. How many different possibilities are there for Sean's password? We have 4 digits. From those 4, choose 2 for the 5s. And then from the remaining 2, choose 2 for the 3s. And that's it. So 4 choose 2 is what? 4 factorial over 4 minus 2 factorial times 2 factorial. 2 choose 2 is just 1. Then this is going to be 6, I believe. Yeah. Now you say, well, I just want to do it manually. Okay, no problem. You can just do it manually. Try to figure out the different possibilities. It won't take that long. You just kind of write them all out. So there's 3 of them. I think I can get about 3 more. 5, 5, 3, 3, and then put the 3s in the beginning, and there you go. So these are the 6. So either way, the answer is 6. Triangle ABC has integer side lengths and perimeter 7. Determine all possible lengths of side AB. Okay, so we've got some triangle here, and we can label it A, B, C, and then the sides would therefore be A here, C here, and B here. Now, we are told that the perimeter is 7, so that means A plus B plus C is 7. But then we also have to abide by what is known as the triangle inequality. Inequality. And what that says is that any 2 sides, if you add them, have to be greater than the third. That's the only way you can make a triangle. You try it out. This inequality has to hold true. So therefore, any 2 sides, if you add them up, have to be greater than the third side. So these are sort of the 3 rules or inequalities. Okay, so now we'll just make a table and off we go. Let's see what we can get. So we got A, we got B, we got C. And then we'll just see what kind of values work and what kind of values don't work. So here we go. We have side, what do they want? The side AB. Okay, so side AB is this guy right here. Side AB is this one here. So that would be this one. Side AB is C. Okay, so let's just plug in some numbers. Let's say C is 1. That would mean that A plus B would be equal to 6. So we could have 5 and 1, for example. But does this satisfy the triangle inequality? Right? That's also got to be part of the table. And the answer here is no. So, because as you can see, 1 plus 1 would not be greater than 5. So it would fall apart. It would not hold true for that. Okay, let's keep going. How about if you have 1 and then we have 4 and 2? The answer again is no. How about if we have 1, 3, and 3? Here the answer is yes. So that's basically what I'm doing. And then any other combination, the value of C would not be different. It would still be 1. So we don't have to go through, 2 and 4 because it wouldn't really change anything. Okay, now we move up. We graduated up to 2 this time. So we have 1 and 4 as possibilities. Does this satisfy the triangle inequality? And the answer is no. How about if we have 2, 2, and 3? Here, yes. And then, again, we don't need to go any further because we pretty much have done all the 2's. Now we get up to 3. If C is 3, we can have 1 and 3. Does this satisfy the triangle inequality? And the answer is yeah. How about if we have 3 and then we have 2 and 2? That also satisfies. And then once you get down to 4 and 5, you will notice that there's no way of satisfying this triangle inequality. When you try it out, you'll see it can't be done. So therefore, the only values of side AB that are valid are 1, 2, and 3. So side AB, the possible values are 1, 2, and 3. If A and B are positive integers such that A is equal to 0.6b and the greatest common divisor of AB is 7, find A plus B. Okay. So GCD of A and B is 7. And if I make that substitution, it's 0.6 B and B. Okay. So in greatest common divisor questions, I always say think smallest, and I'll explain what I mean by that. So we have to somehow get 7. So this guy and this guy, when you take the smallest prime factors, they've got to equal 7. All right, so let's see here. That means that both of them have to have 7 in it. So that means that 0.6b has to have a 7 in it. And in particular, 7 to the power of 1. And then b obviously also has to have a 7 in it. That's the only way you can get a GCD of 7. And then whatever else that exists has to be different. Because if it's common, then it would end up in the GCD. So we have to fiddle around with this. So what can b be? It's going to be something times 7. And then a is an integer, right? They're both integers. So because a is an integer, when you multiply 0.6 times b, it's going to end up an integer. So what can I put here to make a an integer? Well, if I put 5, I think that will work. So for example, if I put a 5 here, then a becomes 0.6 times 5 times 7, and that makes this 3 times 7, and that is indeed an integer. So that means a, which is this really, right, that's a, is 3 to the power of 1 times 7 to the power of 1. B is 5 to the power of 1 times 7 to the power of 1. So it takes a little bit of fiddling around. And therefore, when you take the GCD of these two guys, think smallest. Okay, now I'll explain. For each prime factor, you get the smallest. So for 3, what's the smallest? Well, here you have 3 to the power of 0, right? So the smallest really is 3 to the power of 0. For 5, what's the smallest? Well, here we have 5 to the power of 0. So the smallest is 5 to the power of 0. For 7, the smallest is 1. So that is really the GCD, which is just 1 times 7, which is 7, which is exactly what they have here. So hopefully that wasn't too confusing. So now we have to find a plus b. Well, b is 35 and a is 21. So a plus b is 21 plus 35, which is 56. The equations absolute value of x squared minus 3 times the absolute value of x plus 2 equals 0, and x to the power of 4 minus ax squared plus 4 equals 0 have the same roots. Determine the value of a. Okay. Well, this equation, if x is greater than 0, becomes just x squared minus 3x plus 2 equals 0. If x is less than 0, that equation becomes x squared plus 3x plus 2 is equal to 0. Yeah. Okay. I think these both factor, so I don't think I need to even use a quadratic. So I think this is 2, 1, minus, minus. So that would mean x is equal to 2 or 1. This one factors, I believe, x, 2, 1, plus, plus. So that means x is either minus 2 or minus 1. Okay, so I guess they're saying that this has the same roots. So I guess we'll just plug it in and see what we get. So we use x equal to 2. We will have 2 to the power of 4 minus a times 2 squared plus 4 is equal to 0. So that's 16 minus 4a plus 4 is equal to 0. And I think this would be this 20 is equal to 4a, and therefore a is equal to 5. Okay. So I guess we'll try, this was for x equals 2. Let's try x equals 1. the other root, and that would mean 1 to the power of 4 minus a times 1 squared plus 4 is 0. So that means 5 minus a is 0, and again 5 is equal to a. So we got the same value. And if you plug these guys in, it would end up with the same result, because you notice you're squaring them, and when you square them, the negative sign will disappear. So you should get the same result, and that same result is a equal to 5.